My dear students, welcome to this series on mathematics. Today we are going to look at the chapter Numerical Methods, Part 3. In Part 1, you remember, we showed to you what is a numerical method, how does it work, and how to find the initial solution. In second part, we actually applied it to a particular problem. In this part, we are going to illustrate whatever you have learned in Part 1 and Part 2 to tackle, how to use them to tackle a particular problem. So, the question is, x cubed minus 2x minus 2 equal to 0. First part of the question says, show that a root of this equation lies between 1 and 2. Second, show that the root is unique. Find an estimate of the initial solution. Fourth, show that the given equation can be rearranged as x equal to 2x cubed plus 2 divided by 3x squared minus 2. Write a numerical method to solve the given equation. And finally, find the root to 2 decimal places. Now, is the equation in the form fx equal to 0? Yes. X cubed minus 2x minus 2 equal to 0. So this is fx. We are told to prove that the root lies between 1 and 2. So I calculate f1, 1 cubed, minus 2 times 1, minus 2. So 1 minus 2, minus 1, minus 1 minus 2, minus 3. F2, 2 cubed. So this becomes 8. 8 minus 4, 4. 4 minus 2, 2. So F1 times F2, which is minus 6 less than 0, we conclude that a root lies between 1 and 2. Now, how do I prove that the root is unique? To prove uniqueness, I use the graphical method. As we said in second part, or the first part, we are going to split the equation so that the nonlinear terms remain on the left-hand side and the linear term goes on the right-hand side. So here I have y is equal to x cubed. I would request you to plot the points. When x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 8. 2 cubed is 8. And then you have the line y is equal to 2x plus 2. When x is 0, y is 2. When x is 2, 2 times 2, 4, plus 2, 6. So, if we plot the graph, this is what we're going to obtain. Y is equal to x cubed and then this is the line y is equal to 2x plus 2. So, when I plot the two, what do we notice? We have only one point of intersection. Only one point of intersection. So, we can take this to be x naught. Unfortunately, your graph is not that accurate to be able to read the value of x naught. So, here, the graph of y is equal to x cubed and y is equal to 2x plus 2 meet at a single point. Hence, we conclude that there is a unique positive root. X is positive. In this region, when x is positive, the curve and the line will meet only at one point. Therefore, the root is a unique positive root. And how did we conclude this? Because the curve and the line meet at only one point. And since they meet at one point, there is a unique positive root. What is the estimate? How do you find the estimate, x naught? As I said, if your graph was very accurate, you would have actually read that value of x naught from the x-axis. Unfortunately, you don't have that accurate graph. So what are we going to do? Since we have proved that the root lies between 1 and 2, I'm going to take x naught to be the average. That is 1.5. Fourth, here, we are told that rearrange this equation. We would like this equation to be rearranged as follows. Now remember, this is a technique that we use to write iterative method. In fact, by rearranging, you can write several iterative methods. So remember, the technique to write your own iterative method is to rearrange. And I want you to play with that equation, rearrange as you want in order to have your own iterative method. As I told you in the first part of this chapter, the iterative method that you are going to write may or may not converge. So here, x cubed minus 2x minus 2 equal to 0 becomes x cubed is equal to 2x plus 2. Now, the x cubed, I'm going to write it differently. So here, you can make x sub Jacob formula to have one rearrangement. You can make x sub Jacob formula from x cubed to have all sorts of arrangement that would give you different numerical method. Here we are asked to show that it rearranges to this form. As I said, this is only one of the form in which this equation can be rearranged. So, what I'm going to do for this rearrangement, we are going to write x cubed as being 3x cubed minus 2x cubed, which is equal to 2x plus 2. Now, why do you think I did that? Because there is 2x cubed here. That was the hint given to me, the 2x cubed. So, I'm going to transfer the 2x here and leave the 2 on the right-hand side. Why leave the 2? Because the 2 remains on the right-hand side. So I will have 3x cubed minus 2x, and then this one goes on the other side, 2x cubed plus 2. Now, remember, I need to have x only on the left-hand side, so I'm going to factorize x, giving me 3x squared minus 2. And then dividing by 3x squared minus 2, I obtain 2x cubed over 2, 3x squared minus 2. This is what we have been asked to prove. So, I had x cubed. I decided to write 1x cubed as 3x cubed minus 2x cubed. Why? Because there was 2x cubed on the right-hand side. So, I simplified that. Now, you can also rearrange this one and show that it reduces to x cubed minus 2x minus 2. So both ways would be possible. Now, once you have got this equation, how do you write your iterative method? Xn plus 1, you just have to add n plus 1 to the left-hand side and n to the right-hand side. This is how we obtain our numerical method. I repeat it. I added the index n plus 1 to the left-hand side and the index n to the right-hand side. And now we are going to use it to find the solution. What is the method that we use? We replace n by 0. When we replace n by 0, what happens? I have 0 plus 1 gives me x1. Replace n by 0 is 2. X naught cubed over 2, 3x naught squared minus 2. So, this gives me x naught we have taken to be 1.5 here, 1.5 cubed plus 2, 3, 1.5 squared minus 2. Now, the final answer has to be given to 2 decimal places. I'm going to keep 4 decimal places in my calculation. Right? So this is x1. Is the x1 equal to x naught to 2 decimal places? X naught was 1.5, so 1.50 to 2 decimal places, and x1, 1.84. Are they equal to 2 decimal places? Obviously not. So what should we do? We should continue. How do we continue? We replace n by 2. Replace n by 1, sorry. So this becomes what? 1 plus 1. This becomes x2, right? x2, this replace n by 1, 2. x1 cubed plus 2 divided by 3 x1 squared minus 2. Of course, as I said earlier, take the accurate 8421. Which gives you x2 to be 1.7729. Now, to two decimal places, this becomes 1.77 to 2 decimal places. Are they equal to 2 decimal places? No. They are not equal. What does that mean, therefore? I need to reiterate again. Replace n by 2. If you do that, you will have x3 as 1.7693, which is equal to 1.77 to 2 decimal places. Hence, the root is 1.77 to 2 decimal places. Now, I want you to try this example at home and rework out all the calculation, draw the graph once again. So, this part 3 has shown how actually you can write the iterative method by rearranging the given equation. And there are several numerical methods to solve one equation. Some of them converge, some of them would not converge. So now we're going to show to you how to write your own numerical method. Write as many different numerical methods as you can to solve the equation x cubed minus x plus 5 equal to 0. Or let's take the equation x cubed plus x minus 5 equal to 0. Now, remember, we said in part 1, how does a numerical method look like? You have only one term in x on left-hand side, and all the terms in x are on right-hand side. So, what I'm going to do, the strategy is to keep 1x on left-hand side. One way to do that x cubed, I transfer on the other side, and of course, I take the cube root, and hence xn plus 1. This is one way to write. It may converge, it may not converge. I would like you to see, use x naught equal to 1.5 to calculate the iterates to know whether it converges or not. Another way to write the iterative method, I could have made this x subject of formula. So x cubed plus x minus 5 equal to 0 gives me 5 minus x cubed. Therefore, xn plus 1 is equal to 5 xn cubed. This is another iterative method to solve the same equation. It may or may not converge. Method 3 I can start by saying, well, x cubed plus x equal to 5. If I factorize, x squared plus 1 equal to 5. So x equal to 5 over x squared plus 1. Adding the index, xn plus 1 is equal to 5. That's another method. So we have already written 3 methods, 3 different numerical methods to solve. You can continue like that. For example, here, x cubed plus x minus 5 equal to 0, x cubed equal to 5 minus x, divided by x, x squared is equal to 5 over x minus 1, which gives you xn plus 1. So, you see, it's not difficult to write a numerical method. However, what is difficult is actually to prove whether it converges or not. You are not required to know how to prove a method converges or not. But what you can do is that we have solved this equation in the second part of the lesson. You can actually use the iterative method with 1.5 to see whether it converges or diverges. So, on this, we'll complete the 3 parts of the chapter on numerical method. Remember, the first part of the lesson, we discuss what is a numerical method, how does it look like, how does it work, how do we find the initial solution using graphical and bisection method. In part 2, we applied it to solve a particular problem. In part 3, we have illustrated that further with another example. And finally, we showed to you how you can yourself write your own numerical method for any given equation. However, it's not guaranteed that it will converge. So, we wish you good stay at home. Enjoy the mathematics series with us. Until next time, it's goodbye from us.